Are the drumlins of Alaska and Africa really that different? This location in the African country of Mali has just about every single type of sand formation. This intricate and beautiful landscape holds keys to a controversial past that even parallels Alaska in multiple ways. Around these drumlins is a disorganized ripple formation. The current pushed the ripples forward and distorted them into lobes as they were transported. You can also see the stream paths around them, just like how braided ripple formations form ripples concentrated in stream troughs. These do the same. Here you can see the valley of two streams, and how one leads right into this path of ripples. You can see many locations of this once you begin to recognize this pattern. Now, if you still think all these features are wind-made, then observe these berms on either side of the stream's valley. These are accretion ridges and form from the river depositing sediments near the bank edge, because the current speed slows down there due to eddies on the edge of the river, which form due to friction with the bank. These berms are huge, even over 1 kilometer wide. Okay, so clearly these are water-made ripples. Now, when we go to the drumlins in Alaska, we see that they also have ripples in the troughs of their drumlins. Disorganized ripples as well. Also, throughout these valleys, there are ripples of the braided stream variety. All over the place, actually. So the big picture of these valleys is that of fluid motion, and not glaciers, which push up moraines instead. But what about the drumlins themselves? Well, let's go back to Africa, where the drumlins are several times larger, better preserved, and shaped more perfectly. Due to the nearby scours, we see evidence of a powerful water current, because it takes erosive turbulence to dig a scour, and wind simply isn't heavy enough to do this. So this gives us a good lead into drumlin formation. And there is a feature of fluid motion that can explain and reproduce drumlins consistently. It's called the principle of laminar flow. This is where the current groups itself into columns within sheet water flow. Perpendicular to this are the ripples, just like what we've seen in both of these landscapes. But if you observe wind on the small scale and the large scale, it is unable to make such perfect patterns. And moving ice just bulldozes sediments into a moraine. But with water, we have a working model for drumlin formation that also accounts for the ripples forming perpendicular to them. Now we have to understand how Alaska and Africa could have both had sheet water flow in their past. And that's a more difficult question to answer